Welcome you all to the Stepwise Math channel. Today we'll begin with exercise 7.1 of the chapter Integrals. To know what is an antiderivative, derivative, integral, integration, differentiation and their relationships, you can check my previous video, and also I've explained why constant c must be added after integration, so that you get more clarity on exactly what you're solving. So we will begin with the first heading. Find an antiderivative of the following functions. The first question is sine 2x. So in this heading they have asked us to find the antiderivative, which is also known as integral, by inspection method. So by inspection method, just by knowing some formulas, we can directly come to the conclusion, or we can directly understand what is the antiderivative or integral. We don't need much steps to solve. But let us understand one or two questions very clearly, and then from the third question we can skip many steps. Okay. So the first question is, the function they have given sine 2s, trigonometric function. So we have to find the antiderivative. So it's important to know what exactly antiderivative of this function. So it is that function, if you differentiate it, you will get sine 2x. Okay. So it is that integral, if you differentiate, you will get sine 2x. So this is what we have to find now. We have to find this antiderivative or integral, which we differentiate, we will get sine 2x. That is what they have asked. So this is like a blueprint. Okay. So now let us find this function. For that, if you have observed this d by dx here, you can remember some of the derivative formulas, right? Derivative of x power n, derivative of sine x, derivative of cos x, right? Is it something similar in this way? Derivative of function is equal to, so if you compare these two, see, d by dx of, so this is unknown to us, this is what we don't know, we have to find, and here they have given sine 2x. But since we have done lot of problems in continuity and differentiability, we know that if on the right hand side if we get sine, definitely the function that we differentiate must be cosine, right? But here they have given sine 2x, but actually it is minus sine x. But definitely we will be using this root function. So these are very important functions. Like they are the parental function that help us to solve the remaining other functions which they have done some different arithmetic algebraic operations. So if we see, observe this one, d by dx of some function is sine 2x is very closely related to d by dx of cosine function is equal to minus sine x. So we will apply this and we will solve. Let us solve every step, and then once we get very clarity on, once we gain good insight, we can avoid some steps. Okay. Yes. So d by dx of what function is sine 2x. So we will write this first step, d by dx of cos x is equal to minus sine x. Now we did not get what we want. We want sine 2x, the angle is 2x. So what we will do here is we will differentiate cos 2x. So if we differentiate cos 2x, we will get minus sine 2x, and we have to differentiate this 2x. If you differentiate 2x, you will get 2, right? Derivative of, so d by dx of ax is a. Okay, so when you have 4x, 5x, 7x, you will directly write that constant. Okay. See, again we did not get what we wanted. Like we want sine 2x, but we have minus sine 2x 2. So we want to delete this minus sign, we want to delete this 2. So how can we do it? We know minus into minus is plus, right? And if we divide this by 2, 2 by 2 will become 1. So one thing we have to multiply by minus 1, and we want to divide this by 2 also. So let us combine that and write multiply by minus 1 by 2. So what if you multiply by minus 1 by 2? So this will become minus 1 by 2 into d by dx of cos 2x is equal to minus 1 by 2 into minus 2 sin 2x. Now this implies, so here you have constant and derivative of the function. So how do we simplify that? So here when you have constant into derivative of the function, we will write d by dx of constant into function. So I'll write here d by dx of constant into function is equal to, so minus into minus will become plus, 2 by 2 will become 1 and we are left with sin 2x. So if we just compare with what the blueprint here, can just compare with the blueprint. So d by dx of what function will give us sin 2x? So d by dx of minus 1 by 2 cos 2x will give us sin 2x. So what we can write the conclusion here? The conclusion we can write, therefore antiderivative. So what is another name for antiderivative is integral. Integral of which function? Sin 2x is minus 1 by 2 cos 2x. So this completes the first question. So we will also write here. So derivative of minus 1 by 2 cos 2x is equal to sin 2x. Now the second function, cos 3x. So they have given another trigonometric function. We have to find an antiderivative of this. The blueprint is here. Derivative of which function gives us cosine 3x? What is that function? We call it as antiderivative or integral. So from the list of formulas, we know when we have cosine 3x or cosine function in the right hand side, what is that function? Can we recall? Derivative of which function will give us cosine function? See, derivative of sine will give us cosine. So this is the foundation for us. We will use this. We're going to build cosine 3x. Okay. Now d by dx of sin x is equal to cos x, but we want cos 3x. So we will differentiate sin 3x is equal to cos 3x, and we have to differentiate this 3x. So derivative of 3x, constant into x, it will be constant. So cos 3x into 3. But actually we want cos 3x. So we want to delete this 3. So what we will do? So when you have some in the numerator and you want to cancel it, you have to put something in the denominator, right? So because multiplication and division will cancel each other. So we will write multiply by 1 by 3. You can also write divide by 3. But this is more appropriate, like when you have 1 by 3, one complete value will be there here. So multiply by 1 by 3 on both sides. So here you will write 1 by 3 into d by dx of sin 3x is equal to 1 by 3 into 3 cos 3x. Right? So when you have constant into derivative of the function, just now we solved the similar type, right? When you have constant into derivative of the function, you have to write in this form, that is d by dx of 1 by 3 into sin 3x is equal to, so when you have 3 by 3, when you have same numerator and denominator, it will become 1 into cos 3x will become cos 3x. So now it is something that we really wanted, cos 3x and cos 3x, right? So which is that function you differentiated? So 1 by 3 sin 3x. So if you differentiate this, you are going to get cos 3x. So we will write the conclusion. Therefore, antiderivative integral both are same of the given cosine 3x function is equal to 1 by 3 sine 3x. Okay. So let us fill in the blueprint. It is 1 by 3 sine 3x. Now the third function, e to the power 2x. So this is an exponential function. The base is e, exponent is 2x. We have to find the antiderivative or integral. So the blueprint is derivative of which function will give us e to the power 2x. So we have to find this function, we have to find this antiderivative or integral. So if we want exponential function in the right hand side, which is that function that we will usually differentiate for exponential function. So d by dx of e power x will give us e power x again. So if you have exponential function, the same thing you will get back, right? So d by dx of what we have to write here, so that we will get the same thing, we have to write e to the power 2x. So this is a foundation for us. Let us write down that d by dx of e to the power x is e to the power x. So this implies d by dx of e to the power 2x will be e to the power 2x. But wait, we have to differentiate this 2x also, right? We should also differentiate that function which is there here. Here it is just 1x. So here you will get 1. That's why we will avoid writing that. But here we have 2x. So if you differentiate 2x, what you will get? So d by dx of e to the power 2x is equal to e to the power 2x, and derivative of 2x is 2. Now what we have to do here, because we don't want 2, no? So in the blueprint we know it is just e to the power 2x. So we don't want 2. So we will multiply by 1 by 2. Multiply by 1 by 2. So if you multiply by 1 by 2, you will get 1 by 2 into d by dx of e to the power 2x is equal to 1 by 2 into 2 e to the power 2x. So this implies, so when you have constant into derivative of the function, how do you write it? D by dx of 1 by 2 into e to the power 2x is equal to 2 by 2 is 1. So we are left with e to the power 2x. So what is the antiderivative? If we compare these two, the function, which is that function, if we differentiate, we will get e to the power 2x, that is 1 by 2 into e to the power 2x. So therefore we will write antiderivative or integral. So directly we can write is 1 by 2 e to the power 2x. So this is that function. If we differentiate, we will get e to the power 2x. So we'll write here 1 by 2 e to the power 2x. So which is that step we could have skipped here? Here we could have skipped this step, multiply by 1 by 2. Because we know when e to the power 2x will give us e to the power 2x. And we know we are left with 2, right? So if we don't want this 2, we will divide 2 here and we will divide 2 here. So directly we would have written e to the power 2x by 2. Okay, in the upcoming problems we will solve in that way. Now let us solve the fourth one. Now let us solve for the fourth function, ax plus b the whole square. So quadratic function, because here the degree is 2, no? Now we have to find the antiderivative. That is, which is the function, if you differentiate, you will get ax plus b the whole square. We have to find this antiderivative, integral, the function, primitive function. So now if you observe clearly, there is a base and exponent. So from the list of formulas, which is that function, if you differentiate, you will get some base and exponent value, a number. In the place of exponent you will get number. See, it is x power n See, d by dx of x power n, here's a number is there, no? X power n, some value integer will be there, is equal to n into x power n minus 1. So when you have x, here also you will get x. Here also you will get a quantity, here also a quantity. So x power n minus 1. Base is same. So here we have ax plus b as the base. That means here also we have to write ax plus b as the base. But here what is the power we have to take? When we here we have 2. So which is the power we have to take for the base here? Let us compare with this. So if you observe n and n minus 1, n is greater, no, by 1. N minus 1 is lesser. So here if you have 4, 4 minus 1, 3. So here if you have 5, you will get 4. So here if you have 100, you will get 99. So one extra, one more will be there. So that means if you here you have 2, what is the value of the degree you have to give for the base? 1 more, right? That is 3 you have to give. So we know the base and we also know the degree now. So let us write down that. So d by dx of the base ax plus b and the exponent is 3. So if you differentiate this, what you will get? 3 into ax plus b to the power 3 minus 1 into, but thing doesn't end here. We should also differentiate this, right? Because this is a composition of function. We have to differentiate it inside function. So d by dx of ax plus b. Now this implies d by dx of ax plus b the whole cube is equal to 3 into ax plus b the whole square. And how do we differentiate this? D by dx of ax plus d by dx of b. Now this implies, so what are the things we are supposed to cancel? We'll do it after this step. So d by dx of ax plus b the whole cube is equal to 3 into ax plus b the whole square, and derivative of ax is a and derivative of constant is 0. So I'll not write that, we'll just write a. Now we've got ax plus b the whole square. So we want to delete this 3a. So here we can directly write divide by 3a. We can avoid that step and directly we can write divide by 3a. But let us do it. So multiply by 1 by 3a. So here you will get d by dx of 1 by 3a into ax plus b the whole cube is equal to ax plus b the whole square. So which is that step that we have skipped here? We have directly written 1 by 3a into ax plus b the whole cube. So what is the antiderivative? Let us compare these two. The antiderivative is 1 by 3a into ax plus b the whole cube. So antiderivative or the integral is 1 by 3a into ax plus b the whole cube. Let us write down here 1 by 3a into ax plus b the whole cube. Fifth function, sin 2x minus 4 into e to the power 3x. We have to find the antiderivative. So derivative of which function will give us sin 2x minus 4 into e to the power 3x. So here till now we just had one function, but now we have difference of two functions. So when you have difference of two functions or sum of two functions, and that too if they ask you to find antiderivative by inspection method, we will do it separately. First we'll find the antiderivative of sin 2x. We'll find the antiderivative of 4 into e to the power 3x. Then we will combine and we will write here. Okay, we'll tell you why we have to do it separately. Why not do it as a single shot? Okay, so first we will solve for sin 2x. So first we will find the antiderivative of sin 2x, then antiderivative of 4 into e to the power 3x. Then we will subtract because there is minus sign here. So which is that function? If you differentiate, you will get sine, that is cosine, right? So cos 2x. So if you differentiate cos 2x, you will get minus sine 2x, right? Because derivative of cos x is minus sine x. No, derivative of cos x is minus sine x. But we have to write minus here. So we know that whatever extra thing that comes here, we will put it this side, right? So can I write directly minus cos 2x? So whatever, if you have minus, what you will do, multiply by minus 1 on both sides. So you will get minus here and here you will get positive. So we will bring that minus inside. So derivative of minus cos 2x is sin 2x. Now we will differentiate this 2x. So if you differentiate this 2x, you will get into 2, right? Sin 2x, okay, we'll write here 2 sin 2x. So finally what we will do, we'll divide this 2 also, because we want to delete this. So when you delete this, where does that 2 go? It comes in the bottom, right? So minus cos 2x by 2. So derivative of minus cos 2x by 2 is sin 2x. So d by dx of 4 into e power x, this one, right? D by dx of e power x is e power x. So what we have to write here, we'll try to do this directly. So in 4 into e to the power x, so we will write 4 into e to the power 3x. So we will get 4 into e to the power 3x, but we should also differentiate this 3x. No? So when you differentiate this 3x, you will write 3 here. But what you will do at the end, you will divide by 3 or you will multiply by 1 by 3. Then this 3 and this 3 will get cancelled. Here the divide by 3 will get retained. So what we can write here? We will write divide by 3. Okay. So when you have into 3, I'll write in that yellow sketch pen. So when you have into 3, what you will do? Divide by 3 on both sides. So 3 and 3 will get cancelled, but here it will get retained. So multiplication and division are opposites of each other. They will cancel each other. No? So this is the antiderivative. So now let us combine. So if we combine, what you will get? So d by dx of minus cos 2x by 2. Here we have minus sign. So we'll write minus 4 into e to the power 3x by 3 is equal to sin 2x minus 4 into e to the power 3x. So this is that function. If we differentiate, you will get this. So this is the antiderivative or integral. But now the question is, why didn't we do it together? Why we have to do it by parts? If you do it together, what will happen? I'll write that step. So d by dx of minus cos 2x by 2, and here you will have minus 4 into e power 3x by 3. Now if you want to cancel 2 here, you have to write 2 here, right? Now even in this place also you have to write 2 if you do it together. Now here you want to delete 3, right? So what you will do, here you have written 3. So here also you should have written 3. So in order to avoid this as a change of the main function, we will do it part by part and we will combine the antiderivatives. So this is the antiderivative. So we'll write here, it is minus 1 by 2 cos 2x minus 4 by 3 e to the power 3x. So this is the antiderivative. Therefore, antiderivative or integral is minus 1 by 2 cos 2x minus 4 by 3 e to the power 3x. So this completes the first heading.